So welcome back everyone, and let's quickly go over the initializer lists one more time, because today we'll be using in our project constructors with initializer lists. So topics related to initializer lists and topics related to some of the syntax associated with them will be quite helpful. So in our classes, this keyword is present within each member function. So when we have a class such as point, and we have some function here defined inside the point class, what happens is that this keyword is present. So what does it have? Let me actually go and create maybe a new project, so we can try to experiment a little bit with what we have. Substring demo, something like that should work for today. So I have a class substring. It can be anything with just a name, substring, right? And I try to define a class here, and what I can do is in my main function, I can create this class, because it's already defined, and then I can call a member function. And for the sake of demonstration, what I can do is say public string get string. So I have a function inside my class that returns back a string object and return something like this, debug, just really anything, just to make sure that I can compile. I will of course include string, and we should be able to compile it. So for the simplicity's sake of this demonstration, just using namespace std, and make sure that we can compile as quick as possible. We'll replace some of this stuff at some point. Well, anyway, so nothing really interesting is happening here. I can also include, so it all compiles, right? So I can include, let me just say, reduce this toolbar a little bit. Include IO stream. And here I can say cout string stir equals this, cout display string, print new line, and if I run this, it just prints debug on my screen. Okay, good. So it prints that. So what happens here is that we have a definition of the class in one piece, and we create this class. Then, for the sake of demonstration, we call a member function of this class, and we get something back. We get a string back, and we display that string. It all compiles. It's very standard code. Now, once created, this object here, sub, is essentially the reference, not the reference, but the identifier of our object. So we say that this is our main, like main stack frame, which holds all of our local variables. The substring object is created directly as a local object of our main program. Now, I could do this differently, and the second time I could say substring pointer. Declare a pointer to the substring. And then later on, go ahead and create this object by using new. Okay? So that should work too, create new substring. But this time, to be able to display the result, if I want to use my pointer, I have to use pointer to member dereference operator to get to this member. So again, I get my string, and I'll just replace what I have and print that. The point of this demonstration is that when I say new, we know that the new object is allocated on the free store. And the picture changes is that now we have a little pointer the second time. Small little pointer which remembers the address, right? The new operator allocates, like looks up how big space is required to accommodate this class instance in memory. Then it does that, allocates space in memory, and then calls object constructor. We never define any constructor, so it's like system supplied default constructor executes. But the picture changes that the new returns back the address of this object, and so the object is now created on the free store. So we don't know where that is, but it's created wherever was a memory available, and our pointer is linking us to this object, right? So it's allocated elsewhere. Now, let's go, hopefully everybody is comfortable with this, that if I create object directly, like local instance of an object, I use the dot operator to access my member function. If I have a pointer to this object, right? So some little piece here which contains the address and points to an object in memory, then I have to remember to use this operator. This is a pointer to member dereference operator. It essentially converts pointer to a real object and makes it, access the real string, the getString member. So inside getString, I can still find my object in memory. So if I call getString and getString maybe somewhere else in memory, this is getString. So getString never gets any parameters, but because it's a member function of this class, it is guaranteed to have access to the instance of our object in memory. So let me do something inside here, like int member dummy, right? So if our class does contain something in memory, and it's like this little integer or this little integer, right? We probably need the constructor to initialize it with some value. But there are two ways to get to dummy from inside the member function. First is to simply say mdummy equals 1, 2, 3, 4, 5, right? But a more explicit way of doing this would be to say this mdummy. Now, this keyword represents a pointer, essentially a hidden pointer that every member function has, so that it can be used to access the instance of object in memory. For example, right here, right here, I can. This is getString, and for some reason I wanted to go and find my object in memory. I could do this in main, right? In main, I had a pointer that was pointing to the substring. I also had a sub, which was the local object, so I could access both. But when I am inside my member function, I can still use a pointer to my object, and it's given to me through this keyword. For another example, void foo, I don't know, a demo function. If this function required a substring pointer as a parameter, right? So if this function required a substring pointer to the parameter, and I needed to call this function from getString, then what I would do is that I can easily do this by saying foo and pass this as a parameter. Okay, so this is an example of how I can call member function of my class, right? So this is member function that belongs to this class, and I can, if I need to pass the entire object to some other place in my program, I can simply use this pointer. Yes?
So you pass the whole function getString?
How this works is that I'm kind of struggling with this idea. If I pretended for a second, let me just pretend that. Let me clear this up. And you know how I like to picture my objects as like little boxes, because they're like physical resource allocated. So if I pretended that function foo and getString were a part of this object, which they're not, they're really not. But if I'm pretending that this is foo and this is part of my object, and this is, getString function, which also part of my object, and I also have this dummy right here, right? So if I pretend, so what happens is that any member function of our class can find where the object is through the this keyword, right? So any function that executes for this particular instance can immediately find object in memory. That's what it is. It's like a hidden, in fact, typically on Intel platform, register ECX contains address of an object in memory. So just something to kind of remember that this is available. Now, keyword this is not available outside of the context of the class, right? So this is wrong. This what, right? It's like this is main function. It's not associated with any classes. So this doesn't apply. It doesn't exist here. But as soon as we begin to go into our functions, we get this. What's interesting about this that you cannot change it. You cannot say this equals, I don't know, 0. You cannot change that. It's constant. It's the pointer itself is constant, that you cannot point this to anything else. You cannot assign anything new to it. So that's not allowed. However, anytime your function needs to find where is my object in memory, it just uses the this keyword.
Is it like an address of?
Absolutely. It's like, give me the address of my object. So it's available, and it's very important that it's available. Because very often you may need to just pass, call this function, and then call something else and pass the entire object to that other function. By the way, sometimes this function may be expecting a reference, right? A reference to, I'll call it R sub, right? A reference to substring. In that case, to be able to initialize, to start with pointer and initialize reference, you simply dereference to this pointer. Remember, dereference pointer is actually like if this was a real object created directly here in this context. And when you have this object, this is how you use pointer to initialize a reference. It's you have to dereference the pointer so that the pointer becomes the something of this data type, right? So because before this used to be the pointer to substring, but you want this to be a substring because substring instance can then be used to initialize a reference. In that case, you can't simply do this. You need to dereference the pointer and notice that this is still a reference is very much like a pointer. It just uses different syntax to access object through this reference. Then what happens is that no copies are produced, right? So we're basically saying, okay, this is our object. Use this object to initialize this reference, and then you can use the reference, right? So this reference is like another object, pointing to another object of the substring class. So just a few demonstrations of this pointer. And so here we have a point class, and it contains a couple of coordinates x and y, and the just member function basically increments by x and y, increments member x and member y variables inside of our class. And so it's not required, but you could write code like this. This is my object, and inside my object I have mx and my. And yes, indeed, you have that. So right here, it's sort of like redundant, not necessary, and kind of overcrowding the code with this explicit reference to an object in memory. But it's there, so it's legal. Okay. So sometimes you can have a function which returns reference as well, right? So sometimes function returns, I can say get reference to my substring object and say that it doesn't take any parameters, right? So in that case, I have an instance. Let me see. Let me just get rid of this portion of this demo. Instead, I will say, all right, I have the sub, but I want to. So now my perhaps void foo is expecting a substring passed by reference. Right? So then this work display string. I'm sorry, display. Let's just say display. So to display this, we call display. Okay, so that should work, and this code should work too. So if I get reference to the substring, I can be using it, and I could write code like this. All right, so let me get rid of the pointer temporarily. So in this case, what I do, I create a substring, I call display, and pass my object. However, copy is not made because the function only pretends that it takes a copy, but in reality it's using a reference to this particular substring that I've created in main. So in that case, a reference is just used as a normal substring. Typically, no one does this. Just a sub would be a better name for this. And from this point on, once initialized, pretend that this is a real object. But here's something interesting. We could, I don't know where best to demonstrate it, but I could create, let me get rid of this, make it shorter. I could say, this is really not exactly the right demo, but I could do this. Substring reference r sub equals sub get a reference. All right, so kind of silly code. Create a local reference to a substring and ask substring for the reference. In that case, what I need to do is I need to return reference to myself. I'm actually asking this to provide a reference to its instance. In that case, exactly the same thing happens. I need to return this, but this is a pointer. It would be good for returning a pointer. But my code is structured that I need to return a reference. Then I need to dereference this to be able to return. So another example of this usage where we're need to return a reference to our object from some function, and here's a demonstration of doing this by calling getRef. And again, I can't think of a good example right now, but perhaps in some of our slides there will be better examples of this. So we need to get more or less comfortable with this because, again, every member function gets this, which helps that function, if necessary, to locate that object in memory. As any pointer, it's a pointer. It can be dereferenced, and then it can be used to produce a copy of an object or initialize a reference to that particular data type that we're dealing with. And so these are pretty much all the possibilities that I can think of with respect to this pointer. Perhaps let's see if we can take a look at this. Because this pointer, this is a pointer to the current object, meaning that we say current object is that when I call when I call getString, it's a member function. I cannot make getString call inside my substring class without an instance, right? Instance has to be known and available in order for me to make this call. Then inside this function, essentially, we can say that, well, getString, if it was invoked, then it was invoked on some object. And that's what I refer to by saying current object. So sometimes we want a member function to return a reference to the object was called. So we can, for example, say, again, using some sort of a string as an example, then we can call append operation. We can say, all right, I have string 1. Let me demonstrate this. By the way, let's try to save this fragment, see what happens.